In this video, we are going to be solving rational equations. There are 5 steps for solving rational equations. Step 1 is to factor the denominator and find the least common denominator. Step 2 is to distribute the LCD to the numerators. Step 3 is to simplify. Step 4 is to solve. And step 5 is to check for extraneous solutions. When we start multiplying both sides of an equation by variables, we can get extra solutions that aren't actual solutions to the original problem. And so to check for extraneous solutions, what you're going to do is you're going to find your excluded values and see if those excluded values are some of the solutions that you got. And I'll show you what I mean when we do each problem. So let's try example 1. It says solve each rational equation, check for extraneous solutions. When I look at my denominators, there is nothing to factor. Each of my denominators don't only have, they're all monomials, so there's nothing to factor there. So the other part of step 1 is to find the least common denominator. The least common denominator for this equation is going to be 2x. So what I need to do now is multiply each fraction by 2x. And this is 2x over 1. So we're really just multiplying the numerators. So I'm going to do 4 by 2x, 5 by 2x, and negative 11 by 2x. 4 times 2x is 8x. 5 times 2x is 10x. And negative 11 times 2x is negative 22x. So again, this is like 2x over 1, and so we're just multiplying the numerators and the denominators stay the same. My next step, step 3, is to simplify each fraction. So we can reduce here. So when I look at this first fraction, I have 8x divided by 8. Well, x divided by x is 1. So here I can cross off my x's, and that just leaves me with 8. For my second fraction, I have 10x divided by 2. That's 5x. And for my last fraction, x divided by x is 1. So that just leaves me with negative 22. So then from here, what I can do is I can go ahead and solve this equation. This equation is a lot easier to solve for than our original because all of our fractions are gone. That happened because we multiplied by the least common denominator. If you're somebody that can see this step right here of multiplying everything by 2x and go straight from this step right here to this step right here, then 100% you can do that. I'm just always going to show you out all the steps, that way nobody gets lost in between. So now I'm going to solve this linear equation just like how you learned to do in Algebra 1. You want to get x alone. So to undo addition, I am going to do subtraction. And I'm going to have 5x is equal to negative 30. Divide both sides by 5. And get x equals negative 6. From here, I need to check to see if negative 6 is actually a solution. So I need to check for extraneous solutions. To do that, we find our excluded values. To find your excluded values, that's when you set your denominator equal to 0 and solve. Now you only have to set denominators equal to 0 that have a variable in them. Right here, dividing by 2, I can do that. The whole reason why we check for excluded values is because our denominator can't be 0. This 2 is never going to become 0. But if this x was 0, then that wouldn't work. So here, x cannot be 0. So our only stipulation is that x can't be 0. We got x equals negative 6. So negative 6 can be a solution. So this is our answer. Now, let's say if you got negative 6 as an excluded value and negative 6 was your answer, then you wouldn't be able to do that and you would have no solution. If you had more than one solution here and one of them was an excluded value, then you would just remove that value from your list of solutions. And don't worry, we're going to do more examples like this. Let's look at example 2. First thing we want to do is we want to factor if we can. When I look at my denominators, there's nothing to factor. X minus 2 is linear. So my LCD is the only denominator that I have, which is x minus 2. When you're multiplying, you have to multiply every single term. So I'm going to multiply this fraction by x minus 2. I'm going to multiply 7 by x minus 2. And I'm going to multiply the second fraction by x minus 2. Again, you're just multiplying the numerators because it's like over 1. And when you multiply fractions, you're multiplying straight across. So for this first fraction, if you can see that this x minus 2 is going to cancel out with this x minus 2, then you can go straight to saying, okay, that's going to be 5x. 7 is being multiplied by x minus 2, so I have to use a distributive property. That's going to give me 7x minus 14. And then here, my x minus 2s are going to cancel, and that just leaves me with 10. From here, I have a linear equation that I can solve for, just like how you did in Algebra 1. First thing that I'm going to do is I'm going to get my x's on the same side. So I'm going to subtract 7x on both sides. So I'm going to have negative 2x, and then negative 14 plus 10 is negative 4. To undo multiplication, I'm going to do division, and I'm going to get x equals positive 2. I found my solution. Now I'm going to check to make sure it's actually a solution by finding my excluded values. So let's see. The only denominator that we have in our original problem is x minus 2. X minus 2 can't equal 0. So let's see what happens when I solve that. I'm going to add 2 to both sides, and I get x can't be negative 2. X can't be negative 2, and that was the only solution that we got. So if x can't equal 2, and that's what we got as an answer, then our solution is no solution, because our only solution was an excluded value. So the answer to number 2 is no solution. Let's check out example number 3. On this one, you always want to factor your denominators first. It's going to make your life easier in the long run. When I look at example 2, I see that I can factor this right here. So that's going to be 2 over x times x minus 1 over 1 over x minus 1. So it looks like my least common denominator is going to be x times x minus 1. So that is what I am going to multiply both of these by. When I do that, x times x minus 1 eliminates with x times x minus 1, and that just leaves me with 2. Over here, x minus 1 eliminates with x minus 1, and that just leaves me with 1x, which is x. Well, that was easy. Here we found that x was 2. Let's find our excluded values and check to see if 2 is an excluded value. So I have to set each of these equal to 0. So I'm going to have x times x minus 1 can't be 0, and x minus 1 can't be 0. So if I solve this, I'm going to have x can equal 0, x minus 1 can't equal 0, and x minus 1 can't equal 0. Right here, I'm just setting each factor equal to 0 here. And so I know x can't be 0. If I add 1 to both sides, x cannot be 1. And then same thing over here. If you add 1 to both sides, x cannot be 1. So x cannot be 0, and x cannot be 1. We got x equals 2, so that is okay. So 2 is a solution. Now, some of you might look at this problem and say, okay, well, couldn't I just cross multiply to solve this? And the answer is yes, absolutely you could. You could multiply these together, you could multiply these together and solve that way. In this example, it's going to give you a quadratic, and so you'll have to solve that quadratic using one of the 4 methods that we learned in a previous unit. This way is the easier way. Excuse me. And let's go ahead and look at example 4. Again, your very first step should always be to factor. There is nothing to factor in my first fraction, so I'm going to go ahead and bring that one down. In my second fraction, x squared minus 1 is a difference of 2 squares. That's going to be x plus 1 times x minus 1. And then 3 doesn't have anything to factor. So when I look at this, my least common denominator, LCD, is going to be x plus 1 times x minus 1. So I'm going to multiply each of my terms by that. So I'm going to multiply this one, x plus 1, x minus 1. This one, x plus 1, x minus 1. And this term, x plus 1, x minus 1. You multiply everything. It doesn't matter if it's a fraction or not. Every piece, every term gets multiplied. So if I go to simplify this, x plus 1 eliminates with x plus 1. And that's going to leave me with x minus 1 times 4x plus 1. To multiply this, I'm going to distribute. So x times x is 4x squared. X times 1 is 1x. Negative 1 times 4x is negative 4x. And negative 1 times positive 1 is negative 1. And that's going to equal. Here, x plus 1 eliminates with x plus 1. And x minus 1 eliminates with x minus 1. So that just leaves us with 12. And then over here, x plus 1 times x minus 1, if you multiply that all out, you're going to have x squared minus 1 because you get x squared plus x minus 1. So these eliminate, leaving us with x squared minus 1. And then that is still need to be multiplied by this 3. So that's going to give me 3x squared minus 3. From here, I see that I have a quadratic, right? Because my highest exponent is 2. To solve quadratics, the very first thing that you should do is get everything over to one side. So I am going to subtract 3x squared. And let's just start with that. So I'm going to have x squared. X minus 4x is negative 3x minus 1. And then 12 minus 3 is 9. So I want to get everything on the same side. So I'm going to subtract 9 on both sides. And I'm going to have x squared minus 3x minus 10 equals 0. Here I have a quadratic. We learned 4 methods for solving quadratics: factoring, quadratic formula, completing the square, and taking square roots. Taking square roots is not going to work here because I have a b term, but I could use any one of the other 3 methods. Quadratic formula works every time, but I can see that this is factorable. So I'm actually going to go ahead and factor this because I think it's going to be faster. So there's no GCF. Let me use a different color. And so let's see. First term goes in the first box. Last term goes in the last box. 1 times negative 10 is negative 10. So here I'm looking for factors of negative 10 that add to negative 3. So that's going to be negative 5 and positive 2. In my top row, my greatest common factor is x. In the bottom row, my GCF is 2. In the left column, my GCF is x. And in the right column, my GCF is negative 5. So I'm going to have x plus 2 times x minus 5 is equal to 0. From here, I can use the principle of zero products and say either x plus 2 equals 0 or x minus 5 equals 0. When I solve this left equation, I'll get x equals negative 2. And when I solve this right equation, I'll get x equals positive 5. So now I'm going to check for my excluded values. So my first denominator was x plus 1. That can't be 0. And my second denominator, we factored that to be x plus 1 times x minus 1. So I only have to solve each one once. Since I already have the x plus 1, I just need to worry about the x minus 1. So here I'll subtract 1 on both sides and get x can't be negative 1. On this one, I'll add 1 to both sides and get x can equal positive 1. So our excluded values were negative 1 and positive 1. And the solutions we found were negative 2 and positive 5. Both of our solutions were not excluded values. So these are both our answers. And then let's go ahead and look at this last example, example 5. Again, the very first thing that you are going to want to do is factor. Again, I can see that this is a difference of 2 squares. So my first fraction is going to stay the same, 3x minus 2 over x minus 2. Here x is being squared and 4 is being squared, so that's going to be x plus 2 times x minus 2. And then I have my plus 1. This looks like our least common denominator is going to be x plus 2 times x minus 2. And so I'm going to multiply each fraction by that. X plus 2, x minus 2, x plus 2, x minus 2, and then this last term, x plus 2 times x minus 2. So let's see what we have. Here, my x minus 2's are going to cancel. And I'll have x plus 2 times 3x minus 2. So I'm going to go ahead and multiply that out. X times 3x is 3x squared. X times negative 2 is negative 2x. 2 times 3x is 6x. And 2 times negative 2 is negative 4. Over here, x plus 2 cancels with x plus 2. X minus 2 cancels with x minus 2. That just leaves me with 6. Plus x plus 2 times x minus 2, this is a difference of squares, right? It's a sum and a difference. That just gives me that, because that's what we got when we factored. X squared minus 4 times 1 is just x squared minus 4. So let me go ahead and combine like terms. So I'm going to have 3x squared. Negative 2x plus 6x is positive 4x minus 4. Is equal to 2 plus x squared. Again, I have quadratics. I can see that because my highest degree is 2. So the easiest way to solve a quadratic is by getting everything over to the same side. So I'm going to go ahead and subtract 2 and subtract x squared. So I'm going to have 2x squared plus 4x minus 6 equals 0. Now, let's see if we can factor this. If I try to factor this, I can see that there is a GCF of 2. And so I'll have x squared plus 2x minus 3 is equal to 0. I can factor this some more. So let's see. X squared, negative 3. 1 times negative 3 is negative 3. So I'm looking for factors of negative 3 that add to positive 2. So that would be negative 1 and positive 3. Here my greatest common factor is x. Here my greatest common factor is 3. Here my greatest common factor is x. And here my greatest common factor is negative 1. So this becomes 2 times x plus 3 times x minus 1 is equal to 0. So now I'm just going to set each factor equal to 0 and solve. 2 does not equal 0. That's a false statement. Here I'm going to subtract 3 on both sides and get x equals negative 3. Over here I'll add 1 to both sides and get x equals positive 1. Now that I've solved, let me check for my excluded values. So I'm going to have x minus 2 can't be 0, and x plus 2 cannot be 0. Add 2 to both sides and get x cannot be 2. Subtract 2 on both sides and get x cannot be negative 2. So my excluded values are positive 2 and negative 2. The solutions that I got were -3 and +1. None of my solutions are excluded values, so my solutions are both -3 and +1.